Welcome. This week in lab we're going to be measuring gas pressures. And first we're going to measure the pressure of air, which we call atmospheric pressure. And our device is an Erlenmeyer flask like this with a two-hole stopper. And one of the stoppers is going to be connected to a pressure sensor. And when we measure the air pressure, this stopper will be empty, the second stopper port. And so air is going to be able to come into the flask through here and get to the pressure sensor, and we will measure the air pressure. Then, after measuring that atmospheric pressure, we'll connect a syringe here with a plunger and add liquid. And as the liquid, after the liquid's been in there for a little bit, some of the molecules of the liquid will evaporate, and we'll get molecules of that gas in the vapor phase, in the air, or in the gas phase with the air. So then we'll be measuring the air pressure and the vapor pressure, and then you'll do a calculation to determine the vapor pressure of that liquid afterwards. Once you've gotten the vapor pressure, you will use your knowledge of the intermolecular forces for those different liquids that we're going to be doing in this way. You'll use your knowledge of those intermolecular forces to rationalize the order of the vapor pressures that you get experimentally. So that's a kind of an overview of what we're doing in the lab this week. To properly answer the questions on the hand-in, it's absolutely necessary that you get good data and this week. And so this pre-lab video is going to be mostly about exactly giving you the details you need to get that good data. In addition, we'll be giving you an accuracy point. So if you do get good data, we will give you a bonus point on your notebook copies before you leave the lab. So we want to give you an incentive to get that good data, to pay attention to the details of this experiment. There are two main problems, or two main concerns that have to be paid attention to in order to get this good data. The first one is that you have to avoid leaks in the system. So we've got to make sure that when we get the system sealed and we're measuring the pressure after we get the liquid in there, and as the liquid's going in, that there are no leaks at all. The second thing is that we need to avoid cross-contamination. We're going to be measuring the vapor pressure of 4 different liquids in the lab this week, and as we transition from one liquid to the next, it's critical that the system gets completely cleared out of the first liquid before we add the second liquid, and also the vapor of the first liquid before we add the second liquid. So those are the two main issues, and now I'll go to the apparatus and show you how to do these things. All right, here is the two-hole stopper that's going to go into the Erlenmeyer flask, and you'll notice that one of the ports on the stopper is plastic, the one on the left here, and the one on the right is a metal one. Be sure that these are well pushed in. You might even want to put this down, the plastic one, and make sure it's pushed in there really well, because the plastic one can tend to work itself a little bit loose over time. But if it's pushed in good like this, that's great. That should seal very well. Now we need to connect the two-hole stopper to the Erlenmeyer flask, but just pushing it in like this, that looks sealed, but that's not good enough. We want to make sure that this really seals. That would leak. So the way to do this, as it describes in the procedure, and by the way, this pre-lab video is not a substitute for reading the procedure, both before you take your pre-lab quiz and before lab. I'm going to get a little water from this water bath on my finger and wipe it around on the outside of the stopper, just the outside, not the bottom. And then I'm going to kind of dab it to make sure, with a paper towel, dab it to make sure that there aren't big water droplets on it. But I didn't dry it. I just dabbed it. So you can see it's still wet all the way around. And then I'm going to twist it in there good and strong. And you heard it, maybe you heard a little squeak there. That's good, and it's good and twisted in there, and you can even look around here and see that it's sealed all the way around. So that's a good seal. If sometimes these Erlenmeyer flasks are, the mouth is a little larger and the stopper will go in deeper. If this, when you do this twisting in and with the slight amount of water on the outside, if it goes to where the top of the stopper is even with the top of the Erlenmeyer flask, that's not good either. That's probably going to leak as well. So be sure that it looks like it's maybe 1/2 to 3/4 of the way in after you've twisted it firmly, and that's a good seal. The other thing, while I'm showing you this, is make sure that this is sealed well. This does unscrew like that, and when you put it together, be sure that that's good and firm there. And not too tight or you're going to strip it, but it should be good and snug. And then the same with the other side, on the sensor side, be sure that this one, that's snug, kind of a good strong finger tight. There will make a good seal. So now the sensor itself is sealed. There's a good seal there. There's a good seal here. The only opening now is this port, this metal port. And so that's the way we want it when we're measuring the air pressure. We're going to put this into the water bath. We've got our temperature probe in here. We've got our gas sensor hooked up to the vernier interface box, and so we'll be able to measure the gas pressure at this point. Then we're ready to move to putting in the liquid. So we take our syringe, and I need to get my goggles on. I should have had them on sooner, but let me suck up 2 milliliters of this ethanol. So I've got there, you see, 2 milliliters of ethanol. There's a little bit of an air bubble at the top. I'm going to try to push that air bubble out without making a mess of the lab here, because we don't want to squeeze extra air into the flask. We just want 2 mils of the liquid. And now we're ready to attach this to the flask. And the way we do that is to tip the flask sideways. Take it out of the water bath, tip it sideways, and attach it this way. The reason for not going like this is maybe you just saw a drip of ethanol came out of this. Some of the liquids have more or less vapor pressure than others, and they will dribble out if you turn them upside down. So turning it sideways like this, we can get it connected without losing liquid. And then screw it in. It's called a Luer lock. The type of fitting is Luer, and it's a lock. And it screws together and seals very, very snugly when you've got it good. So again, don't overdo it and strip the plastic. The metal will strip the plastic if you do it too hard, but be sure that that's good and secure. Now, the whole system, from the sensor all the way, everything is closed. The stopper is sealed, both ports are sealed, and we've got a good closed system. And this, now, don't disturb that system. That's how you get leaks if you mess with things. Now, we're ready at this point to inject the liquid. If the liquid all stays up in the syringe, it won't evaporate as well, and we won't be able to measure its pressure easily. So we're going to squeeze that, and then maybe go in and out a few times to make sure that all the liquid gets in there. But be very careful when you're doing this plunging, that you're not twisting the syringe and causing it to loosen at all and break this seal. We've got to keep the seal down here, prevent it from leaking, and be very careful not to loosen the syringe at all. Then we put the syringe in the flask, wiggle it around a little bit, shake it, watch the pressure, and when the pressure and the temperature are stable, then we can record the pressure that we've got in the system, and from there go on and do the calculations necessary. All right, now if we're done with this liquid, this is ethanol, and we're ready to move on to the next liquid. As I mentioned, the thing we have to avoid is cross-contamination. We have to get rid of all the liquid in this system. All the ethanol has to be gone. So let's start by just taking this apart and pouring the few mils. There may be only 1.5 or 1 3/4 milliliters of ethanol left. We'll pour that back into that beaker, and this will eventually go to the fume hood and be put in the waste bucket in the fume hood that's labeled appropriately for that. I'll put that over there. Now there still may be some drops of ethanol in here, and so we take a dry paper towel and dry it out, because we want it to be completely dry before we use it again. You should have 2 of these 125 milliliter Erlenmeyer flasks in your drawer, so you can use the second one for the second liquid to give this a little bit more time to dry out. But I have dried it. There are no droplets in there now. I'm going to set this aside, and I'm actually going to lay it down. The vapors will come out better if it's laying down, and now that's ready. 2 other things that need to be cleaned here, and the first is the syringe. Let's take the syringe off, unscrew it, and the way to do this is to actually take this apart. It's a little bit stiff, but when you get to the end, use your thumb to push on this part and pull it right apart. All right, and then shake these parts out. Shake them out. Dry them with a paper towel, a dry paper towel. Look through here. You can put a Kim wipe. The paper towels are sort of big, but you can put a Kim wipe down the barrel here, like that. So to make sure that that's dry, you can bang the tip, and I see that there's still a little liquid coming out there. When I do that, coming out of the area in here where the threads are, you want to get the liquid out of everywhere. This has got to be dry. So we do that, and then maybe let it sit on the bench for a few minutes before you go putting it back together and using it for the next liquid. The last thing to get to avoid cross-contamination is to get the liquid out of this plunger. We squirted ethanol through this metal port here, and we've got to get the ethanol out of there too. So again, you can bang that, and you see that some ethanol was coming out. It's wetting the paper towel. Do that till it's not wetting it anymore, and then maybe even blow through here. Blow to make sure that you get all of that out. If there may be some ethanol on the bottom of the stopper, so wipe that off, and be sure that, look through it, be sure everything is clean and dry. And again, wait a couple minutes before you reassemble everything to do your next liquid, and that will pay dividends. You will get excellent data for your second liquid, and you do that between the second and third, you'll get great data on your third liquid. And the last liquid is hexane. Let me say something about hexane, the last liquid. You're going to put it together just like we did before. You're going to measure the atmospheric pressure. So without the syringe, with this properly put together with a little water on the outside of that, squeezed together, you're going to put it in without the syringe and measure the atmospheric pressure. And then you're going to pull up 2 milliliters of hexane in the syringe, attach it as I described, squirt the hexane in, and do the room temperature measurement just like the other liquids. But then you're going to do 3 other temperatures for the hexane. So you will have 4 of these white baths total, the room temperature one, and 3 that are lower temperatures all the way down to ice, 0 degrees Celsius. When you are, so your system will look like this with the hexane in there, of course, and having evaporated, and you measure your room temperature pressure. And then when you go to the other baths, don't change a thing about this. All you have to do is pick up the flask and the temperature probe and move them to the next water bath and wiggle it around in the next bath and wait for the pressure and temperature to stabilize. And when that's done, again, just pick these up, move them to the third bath, stick them in that third temperature bath, wiggle them around, wait for the pressure and temperature to stabilize. And don't change a thing. Don't mess with the syringe. Don't play with that. Just pick it up and move it. That's it. Have fun and get good data. Show your data to your instructor before you leave. And if the order of vapor pressures that you get is correct, you'll get the bonus accuracy point. And if it's not correct, you'll be told where you can get some good data on the D2L site to use for your hand-in, for the questions on the hand-in. But you won't get the accuracy points in that case. So have fun in lab, and I'll see you there.